Hello, welcome back. Today we're going to improve the user experience for installing objects. So where we left off last time, and let me just show you in the app. We made it so that you can schedule a job to install, for instance, this kitchen table. However, there are a couple of issues, such as first, well, you don't have any feedback where it's actually going to be installed, and also you can schedule installation in illegal places, such as in this wall. So that's something that I want to improve on today. So what we're going to do is we're doing polishing of the install object UI. And this will be 3 steps. We will give feedback on where we would install. So we want to show a sort of outline indicating where you hover the mouse, where you're going to be installing the object. We want to indicate whether installation is actually possible at that location. And we want to prevent the scheduling of an install object job in an illegal position. So let's first start with the give feedback on where we would install. So we already have Xcode open, and we will start our work in the object sprite manager. We have our redraw world in scene function. We're going to add some more information to this function to take in a selected object. This will be an optional object and a position. So this will be the intended position for the selected object to be installed. And this too will be an optional because there might not be any. And after we displayed all the jobs, we're going to see if we have a selected object and if we have a position. Then we will get our texture, and we will get a color, and this will be a SK color for calibrated red, green, blue, and alpha. So we want to give it a greenish hue, just like the others, which is semi-transparent. And then we can use our set object texture that we just retrieved. The object will be our selected object at the position that was passed in this scene. And we need to make sure that we call this function. If we try and build it, there's first a different issue. Well, okay, so that apparently are 2 issues. Oh, we're not yet passing in the color. We should definitely do that. But also our redraw, because we changed the signature for this redraw function, we're no longer conforming to the Sprite Manager protocol, because that requires a redraw function with just the world and the scene. So to solve that, we will create a sort of shorthand version of this function that simply calls the larger one, passing in the information that was sent in, and nil as selected object and position. This should now build correctly. Then we need to call this function from our game scene. Here where we're using the object sprite manager to redraw, it should somehow pass in a selected object. This is something we need to fix in a bit. And we need to bring in a position, and the position is the view models hover coordinate. To get the selected object, we would like something like view model dot job object, the object for the job that we want to schedule, but this one doesn't exist yet. So let's go into a view model and add this one. So let's go and find some place where we can create a job object, and this will be an optional object, and this will switch on the current job call. And if this is an install object job call, then we can return this object. Otherwise, we return nil. So let's see if this compiles. Let's see if it runs. Let's zoom in a bit, and let's see if this helps. So we choose install kitchen counter, and now we can indeed see the kitchen encounter outlined, or at least semi-transparently indicating where we would be scheduling to install it. However, we can choose a correct location, but we can also still choose an incorrect location. So that's the second thing we should be fixing. Cool. So to do that, we need to somehow be able to distinguish whether an object can be installed at a certain position. And I think probably the easiest solution is to go into our object and create a helper function here. The func can build in world. And this should take in a world and the position. And this should return a boolean. And now we return false. Let's build up this function from our test. So we don't really have a fault of object test, so I'll reuse the world test. Let's create a new marker. Install object and install in world test. So let's see. So the first test will be to see if an object can be built in the world. And this requires a test object. And let's say we allow it to be installed in the void. Let's create a completely empty world, and let's assert true that the test object can build in world. In this world, at position 0, for instance, and because we call it here can build in world, I think we should use the same name here. So let's see if this test fails. And it fails because we're always returning false. So of course we can say, well, let's return true. Cool. Run a test again, and now it'll pass. However, we probably want to do some more testing. For instance, if our object can build in world, fails for a non-empty tile. So we shouldn't be able to install an object in a location where there's already another object occupied. So let's again get our test object. Let's create a world. And let's make sure that our world, for instance, at the down position, already contains an object named a pre-existing object that is somehow large enough to obscure where we want to install the test object. So let's say perhaps it's 1 wide, but it's 3 high. Then we can insert false that test object build can build in world at position 0 fails. Now let's run the test. The test fails because I think we're always returning true, so we need to do some more, add some more intelligence here. So let's use our world object exists at position. This should be false, otherwise we return false. If this is if something already exists, then this entire statement evaluates to false, meaning that we fall through and we return false. Otherwise, if nothing exists, then we can fall through and go to return true. And the reason we're not just returning the world object exists at position equals false is because this way we can add additional test conditions as we move on. So let's run. Now the test passes. And the final test that I want to install, I want to add is the object can build in world fails for wrong tile type. So I shouldn't be able to install a kitchen table in a wall, for instance. So I need a test object. And let's make it a little bigger. So for instance, 3 wide and 1 high. And the allowed tiles, I can only install it on the floor. Then I create a world. Then I set the tile to the position to the left to the correct tile type. But note, I'm not setting any other tiles to flooring. So all the other tiles remain void. We can actually check on this. So we'll check if world and tiles at position 0 is indeed a void tile. And this should again return false. A test object can build in world. And the position should evaluate to false. Okay, this one fails because we're not yet checking for tile type. So let's go back to the object once more and add an additional check. So what we should do is we should check for the entire size of the object. So we'll go through the Y position all the way towards Y position plus size.y, and similar for the X position. Then we will look at what kind of tile we have in the world at this position. And factor x and y, and we will default to void tile. And then we say if allowed tiles contains this tile. If this is false, so we found a tile that is not in the allowed tiles list, then we return false. If this never happens, we fall through again and return true. So let's go back to our test. Let's run the test. Let's run all the tests except the UI test. And all tests pass. So we now have a helper function that gives us an indication of whether we can build in a world. And we can use this one in our object sprite manager. Let's go. Let's see, we have a color, so we're going to reuse this in a bit. But the color we're going to use here, we're going to do first do world can. I'm sorry. Selected object can build in world at position. If this is true, then we use this color. Otherwise, we use red color. And we no longer need this one. So if we run this one, then we should be able to see that we can't install here, can't install here, can't install here. But once we reach the flooring, we can actually install. But we can't install on the wall, we can't install in voids, and also we can't install when it's overlapping at least one not installable tile, even if we already have one. So we have an object installed, we can install next to it, but once we go over it, oh, I think we have a bug here. So we have a can build in world function. Now I think we were actually already checking this because we already have our object position and I think we were already testing this in here for fields for a non-empty tile. I think we have a logic error. I think if we perform this test to check if the object exists at the position, if we do this for every tile, so let's see if our test still run correctly. Let's run it again. And we install our kitchen counter. Try and install another one, and now indeed it's failing because they overlap. Cool. Okay, so we improved this one. However, notice that let's run it again and let's try and install. So I get an indication that I can't install here, but I can still click and the job gets scheduled. So this is something I would like to prevent as well. And to do that, let's go into our view model. And where we finish our selection, we have an install object one here. Create an install object job. So apparently there was already some placeholder here. We should check if we can actually build in the world at this position. Let's run. Let's try and install. And now we can no longer install in legal positions. But it's working correctly. Notice that our entity is still cooking food. Okay, so these are our 3 goals for today fixed. Next time I want to do some refactoring, for instance, because I'm not happy that we are in this, where is it, world, I'm sorry, object can build in world function. We're rechecking something that is already being checked sort of through a requirement. So we're repeating ourselves, and well, you shouldn't repeat yourself as one standard principle when developing. So next time I want to do some refactoring to clean up this code a bit and remove duplication, also prevent any bugs from coming from that going forward. So for now, thanks for watching and have a good day.